Hello everyone, welcome to the Landtamer stream. We are grinding away at the CCIE written material, getting ready for 68 days from now to do the third attempt on the CCIE routing and switching written exam. In the meantime, we're vlogging the journey, connecting with the community, studying together. So happy to have you along. This is the same wallpaper of the day from yesterday because it's just so awesome. I saw it featured a lot on Instagram and Twitter. And let's see if we can't fix this shadow going on here. Real quick, this is on the video capture device. That needs to go up. And let's adjust this thing real quick. Sorry about that. This is the kind of fun stuff you deal with when your lighting needs a little work here. There we go. So yeah, thanks for stopping by, folks. Let's check out the chat. Hey, Dude for Him is here. I'm going to be talking about you today, Dude for Him, a little bit. And in our studies and our explorations of some of these technologies. So yeah, we're at day 309 of this journey, day 309 of streaming the journey anyway. And we're going to talk about PIM-BSR. We're going to do a little lab. We're going to talk about some IoT security. We're also going to talk about REST API calls, which is very important for API programmability. But first, let's talk a little bit about study. I did finish the lesson I was working on yesterday, which, is AutoRP. So I finished reading through that and looking at some PCAPs and things like that. And I did not have much time today otherwise to study networklessons.com. I was working with Dude for Him on some questions of IoT security, etc. So we're a little all over the place today. Also at work, I was all over the place. I did a little bit of work with EIGRP, with BGP. I got to do some routing stuff today, which is cool. Lately I've been focusing a lot on cloud. This does involve the cloud, but more of some of the traditional on-premise sort of connectivity to the cloud and how, cloud, BGP and Azure, and anyway, just a bunch of cool stuff and some F5 stuff. So got to do some PCAPs, look at some Wireshark captures. So it's kind of all over the place today, but it was a good thing. No day for me anyway is the same, and is getting to use some of my CCIE learning stuff too, which is good. So let's talk a little bit about IoT security. Where this came up is Dude for Him and I normally in the morning will exchange like a question to each other that is related to the written blueprint, and I got this wrong, half of it wrong, and I'm going to explain sort of my reasoning on this, but it had to do with IoT security. So on the sensors, when is it best to encrypt if you have to choose between data going into the sensor or data going out of the sensor? Which is better? And my answer was data going out. And it seems that is the correct answer, which is good. It makes sense. A lot of the data collection related to IoT, in particular when you're talking about sensors, there are different devices involved with IoT, right? There's a broad categorization. Man, fourth time I got it. There's a broad categorization of devices just called sensors. And that can apply to a lot of different things, a lot of different industries, a lot of different applications. But generally, you want to, most of the data that you are interested in or that could even contain sensitive information, like medical devices, what you want to encrypt data that is coming from or leaving the sensor, right? Data that is a result of acting as a sensor of some sort of, data points. So that's generally where you want to encrypt, right? If you have to choose, you don't want to choose data coming from the sensor. By far, there's going to be the majority of the data that you're looking for, right? data analysis of the IoT data. So you got all this data, for example. Let's say you've got a warehouse full of sensors. Where's the best place to do data analysis of that data? Now, I got this part wrong, and I'll explain what my reasoning was and why I understand that better now. So I said at the core, and the reason I said that is because of fog computing. And this is a concept I've also learned about related to IoT, and I'm not an expert on IoT by any means, folks. I am like struggling a little bit on this. So, but I have done some study of it. I've taken several days previously to try to kind of summarize IoT and learn about it. And one thing was fog computing. Fog computing is a concept of basically at the aggregating data from your sensors or from IoT in general, any type of IoT device. So IoT devices tend to be numerous. The data can be significant that is coming from IoT devices, and generally it is there's a lot of latency in the communication between your IoT devices and wherever you want that data to go, right? Whether it be at the core of your network or whatever the case may be, or to the cloud. Get it? Fog, cloud, but fog computing is essentially, the concept is to, at some point in between, to try to aggregate that data. And because there's a potential that a lot of that data might be useless, a considerable amount. And with high latency communications behind or related to an IoT network, the farther to the edge you filter out that information, the better. If you're not going to use it anyway, and you may sacrifice some of that transfer of data, and you might want to categorize it right and eliminate some of it with the concept of fog computing, so that you reduce some of the latency for the data that you actually want to receive in the cloud or in your network or wherever the case may be. So because of that, I thought, well, it's probably ideal for you to do more of that data analysis in the core. If you're using fog computing, then the majority of your data analysis would be done there after you've sort of filtered out a lot of the sensor data that you don't want anyway. But that is the engineer in me thinking about it, not necessarily the IT security engineer that should be in me thinking about it. Because in reality, and I was really helped today by this link I'm going to share. This is from Cisco Live. This kind of opened my mind up to why security at the edge, which is the correct answer, is important. Now, I don't know if that link will work unless you log in, but if not, the breakout session is BRK IoT 2112. And this is really good because there were a number of applications of IoT that I was not thinking about. In particular, what is called, they tend to categorize some of the IoT data as IT and OT, which I think is referenced in the new version of the Evolving Technologies Blueprint. Let's check that real quick. That distinction between IT and OT is what I'm talking about. Let's see, I have a shortcut to it here. Now, I fixed the shortcut on my desktop. And I actually tweeted this slide out earlier. This is a really good slide. That's probably a pretty broad search. Let's go down to 7.0, which is the Evolving Technologies section. This copy I have of the blueprint is one I made to categorize my weaknesses, and it is using the new 1.1. Here's IoT. They're 1, 2, 3, 4. Yeah, and this kind of gets into the technology stack, network hierarchy, data acquisition. Here it is. Yeah, I thought I'd seen this. IoT standards and protocols, characteristics within IT and OT. And I believe that's, of course, information technology and operational technology. And what I did not think about is, and let's pull it up. Let me pull up that slide. I have not finished the video yet. As you can see, I have gotten about a third through it. It's really good, though. And let me pull up that tweet to check on the slide here. And what I'm getting at is this really opened my mind to, wow, there are a lot more potential IoT vulnerabilities than I had thought about before. You know, I'm thinking refrigerators, smartwatches, things like that. Sensors on the Amazon manufacturing floor, right? But there's definitely a lot more to it than that. So let me pull up my tweets here. Oh, you know what? It was on Instagram. 1 second. Yeah, this is the slide. So the rigid silos between IT and OT. OT is operationals, right? Operational uptime, safety, high availability. You probably can't see that. Integrity, confidentiality, control. When we think about OT, some of the examples given in this talk were in like a traditional factory where you might have devices, electronic devices in the past. Now they might be IoT devices linked into a network. But before, oftentimes you had different controls. Like you might have a control for dumping concrete in one section of the factory, or you might have a control, that moves machinery in the factory that is very dangerous. So really, as those were often kind of hidden, or you might be behind locks and lock and key to get to those, to operate some of that equipment. Now a lot of those things are being tied in. Sensors are being IoT sensors are a part of the equation, and there's more robotics, of course, and some of the controls are being integrated into the network. And those are definitely security risks, right? Especially talking about energy and a lot of industrial areas. And that was what the speaker was really keying in on, is IoT applications in the industrial sector, and how that is really where there could be a lot of safety issues. And so therefore, you really cannot afford to wait to analyze data sometimes until it gets to the core, or until it's filtered out. You might have to analyze data, especially look for security patterns, access violations, whatever the case may be, and the transmission of data. Is it being transmitted securely? Are there attack vectors happening? So really, that is more appropriate apparently at the edge than at the core. When you're at the core, it may be too late to act upon it, or you may not be able to do that from the core. In particular, when we're talking about the wireless communications, things like that, the ranges, you would have more control, of course, near the edge. So that's the impression I got anyway. That's my interpretation. Obviously, this is not a teaching channel. This is just documenting the journey. And those are the things I got out of it. So IoT security, very important for the CCIE written. And really, CCDE, whichever exam you're taking that has the Evolving Technologies 1.1, you need to know IoT, and you need to know IoT security. So good stuff. Great discussion we had, and I appreciate Dude for him helping me out identify a gap there. So moving on to networklessons.com. As I mentioned, I did get through with the RP Auto Lab. Right now, we're going to go ahead and fire up the BSR. So, no, I didn't make any changes. Don't save. So right now, we're going to fire up my VM, which I have not done yet. So let's fire up, let's log into Portal. Hey, thank you, dude, for him. Appreciate that, man. I always worry that sometimes I might be misstating something, so that's why I give a disclaimer. Like, this is my interpretation of the talk, but that talk really helped. That other presentation I sent you, meh, didn't really help me much. I don't know about you. But, and the other thing is, at the beginning of that presentation, BRK IoT 2112, at the beginning I was like, I don't know, it's iffy, but about a few minutes in, it started to get really good in terms of kind of concepts. So it's really good stuff. All right, let's fire up this VM. I need an automated way to do this. What's the other thing? Advisor. This is the Azure Advisor. Pops in once in a while. Enable virtual machine backup for data. Yeah, not too worried about that. And the other, use availability sets for improved fault tolerance. Yeah, that's a pretty cool feature of Azure. It's basically like saying, you know, configure multiple VMs and a load balancer. Instead of, you know, essentially with Azure is always going to advise you never have just a single purpose VM. Always have at least two for redundancy to run your applications, which makes sense, especially with IaaS. All right, so did I actually fire it up? I did not. Let's start her up. And let me load the sort of the lessons we're going to be doing here in networklessons.com. I think I may already have it. Yeah, already got it open. So what I did not realize, well, I had read it before, but it just kind of sunk in for me today, is that when I was reading about BSR, the fact that this is an RFC standard protocol, whereas, you know, I'm kind of new to multicast anyway. In general, I've done some labbing with multicast back when I was just labbing out of the INE workbook. That's about as far as I got midway through the multicast section. It was completely new to me at that time. And now going back through networklessons.com, it still feels very new to me. But I'd forgotten the fact that really I'd been so used to auto RP, but that's really Cisco proprietary, right? And there's some very interesting concepts for BSR, which of course is Bootstrap Router. I love the name. But yeah, instead of, so in auto RP you have, let's compare. In PIM auto RP versus PIM BSR, you have a mapping router, and that uses the RP discover. Shoot, wasn't that the command? RP announce and RP discover. Yeah, so let me use the terminology shown here. So you have a candidate RP, and then you have the mapping agent, right? Or mapping router. Yeah. And the command here, of course, is send RP discover. And the command here is send RP announce, right? However, with PMBSR, you have, let me make sure I'm telling the correct thing here. Look at the router configurations. That's the problem. When you're covering so many different topics, like preparing for the written, it's hard to focus just really on one completely. That some of the details you have to like check on again, because yeah, send RP announce and send RP discovery. Whereas in PIM-BSR, we have some slightly different, and I just closed my window, darn it. We have some slightly different terminology Here we go. So we have the candidate BSR, candidate bootstrap router, and we have the, come on, tabs. Candidate RP. So one really interesting thing about BSR is the fact that BSR uses announcements using hop by hop versus multicast group. And what I mean by that is, and this is, a lot of this is new, was new to me today. So when you're using PIM Auto RP, it actually leverages the multicast itself and multicast groups to do the discovery and the announce, right? We got 224.0.140 and 224.0.139. BSR, when it does an announcement, it kind of, in my mind, operates a little like a switch. So it's sending the announcement out of every multi-PIM interface except the one that it received it on. So instead of sending to a one of these multicast addresses, what address does it use here? Yeah, it uses the PIM. It uses a PIM address like 224.0.1.0013. So 224.0.013, which we know is the PIM router's address. That's what your PIM hellos are sent on, right? Versus multicast groups, 224.0.1.39 and 224.0.1.40. So it uses the same destination address that it would use to send PIM messages, right? Any other PIM message. That's what BSR leverages. So, and it sends it with a TTL of 1. So it's only going to send it to the next, to an adjacent network segment. And then that PIM router will receive the announcement for the BSR, and then it's going to do, like I mentioned, like a switch. It's going to send it out every interface except the one it received it on. So in that way, that's how you can learn about all these BSR announcements on your network. And you don't have to rely on this weird kind of, we got the chicken. You don't have the chicken and egg issue, which is really cool. The other thing that was neat to me is how the candidate RPs. So this is the BSR, the candidate BSR. The bootstrap router is kind of the equivalent to the mapping agent, right? The candidate RP is also in BSR called the candidate RP. Same thing. The candidate RP though is going to try to let the BSRs know that, hey, I want to be a candidate RP, and it's going to send it via unicast, which is interesting, right? So with bootstrap, first we need to learn what our BSRs are, which we learned through these BSR announcement messages sent around the network, hop by hop basis. So then the candidate RP is going to learn, or it can learn, you can statically configure it, right? But it can learn about the BSRs, and it's going to send a unicast message to the BSRs that it learns about. And then an election takes place. And the election this time in BSR is made by each router, which is interesting to me. So in the case of AutoRP, for example, it's the mapping agents that do the elections. They decide who is going to be the RP per multicast group. In BSR, each router is going to decide, which makes for some very interesting election dynamics, and it is described very well in this networklessons.com. I'm not going to go into all that, but there are like 4 different criteria that can be used in a particular order, and one of those uses a hash. with bits that you can manipulate. Yeah, it's pretty complicated, but let's see it in action. So let's fire up even G. And I don't remember my machine name. I should just go ahead and do a bookmark to this thing. I haven't had a chance to rebuild or to build that new VM that I want. So I've just been using this one, but oh well. Boom, fires right up. Folks, it looks like I only use like $1 worth of lab, and this is the big VM. So several hours I had it yesterday, it cost me $1. That's not bad. All right, I think we're going to use the same lab. It has a very similar topology, which would be cool. We'll kind of be able to tear down the previous lab. Oh, does it not give? Yeah, there it is. Okay. Yeah, so let's start all our nodes. And I think we're looking at, yeah, same. It's the same 4 router setup. So we're going to do essentially the same thing, just now with BSR instead of auto RP. There we go. Let's do router 1, router 2, and come on, router 3. Work with me. There we go. Two, three, 4. And what we're going to do is we're still using sparse mode here, of course. Right, because with sparse mode, we need a rendezvous point. All right, see, that came up pretty quick. The only thing I'm noticing here, folks, is that by default, no matter how you save your lab, when you boot the lab up in Azure, I don't know if this is Eve community thing, I'm not sure, but they're administratively down, always. Oh, is that because the image is still loading? That could be. Stream is lagging bad here. Is it for anyone else? Let me check on that, my friend. Sorry about that. I think I know what it might be. It might be this backup that's running. Okay, thank you, Rittenhouse and Dufresne. Appreciate that feedback. Just in case I'm going to kill that backup. Folks, the reason I'm doing a backup right now is because of this. I'm pretty excited about dark mode. I know it's cheesy, but this popped up on my computer this afternoon. I'm like, yes. I want to try that. So I kicked off a backup with Time Machine. But just in case, we'll do that. Yeah, they're still down. Interesting. So I wondered if that was just me or what, but router 3 and router 4. Bring those interfaces up. And let's check the PIM configuration right now. IP PIM RP address, let's take that out. And we're going to take out IP PIM auto RP. I don't think I saved that from yesterday, which is fine. what we'll do is just make sure the interfaces come up, make sure OSPF comes up, and just for verification, we'll check our PIM neighbors. Okay, IPPIM sparse mode. All right, let's do show IPPIM neighbors. And I should have one. I don't have any. Huh, okay. Let's get OSPF going. Now I need practice in that anyway. Where I work currently, like, I was able to get practice with OSPF because we had OSPF on some of the networks, and then that has hence been replaced by EdgeRP. So I don't really get much practice with OSPF anymore, except in labs. And on router 3, router OSPF 1, network. Okay, show IP interface brief. Let's see if we have the loopbacks. We don't. Let's check over here as well. Okay, we do have a loopback and it is up. Interface range J0 1 through 3, no shut. Thought I brought those interfaces up. There we go. Now we're cooking with gas. All right. And show IPPIM neighbor. Okay, we got our neighbor, router 2. Router 2 should have 2 PIM neighbors. He does. Router 3 should have 2. He does. And router 4, does he have a loopback configured here? He does. Or he should. And you do need to enable PIM on the loopbacks. DR change from neighbor. Okay, show IP PIM neighbor. Good. All right, we're not learning the, we don't have OSPF here. All right. Should be good to go. Show IP PIM neighbor. Show IP route OSPF. Not yet. Not here either. We should at least be learning the loopbacks. All right, that's router 3. Let me make sure that's right. 23, 34. We don't need 3.0, but that's okay. Leave it in there. Did these interfaces not come up either? No, they did. Ping 192.168.23.2. Jazz 02. 0102, yes. 12.1. Oh, yeah, that's wrong. That's why. 192.168.34.3. Let's see. Interface Jazz 02. Yeah, something is right here. Show IP interface brief. Oh, that's router. Shoot. Did it wrong. Okay, we got a whole mess here going on. All right, interface Jazz 01. Jazz 02. Okay. Default interface Jazz 03. Do show IP interface brief. 24.2. Nope, that's a typo. Okay. DR from the, all right, show IP PIM neighbor. Show IP OSPF neighbor. All right, waiting on 3 to come around. So router 3, I think we have also. Yeah, that's wrong. Interface Jazz 01, IP address. And interface 02. There we go. All right, and router 4. Yep. Show IP PIM neighbor. Show IP route OSPF. Nice. We don't see 1.1.1. That would be why. Okay. Now we should be able to ping that. Good. All right. So getting on to our, I think the difference here, of course, is, of course, the announcements, right? With the BSR. So I believe in this lab, it wants us to use router 2 as the BSR. Yeah, so let's look at that configuration. IP PIM BSR candidate. Very similar, right? Neighbor down. Wait a second. Neighbor down. We have neighbor down. Neighbor looks up. Neighbor 1 2 3 down on interface GI0. I don't even see that neighbor here. Why would it have that as neighbor? Oh, so DR change. Okay, that's fine. Show IP PIM neighbor. As long as they're back up, which they are. Yeah, okay. Going back to this, IP PIM BSR candidate. And very similar, right? We want the interface is going to be loopback 0 and the hash. So I won't go into explaining all this. Essentially, if we do 32 on, like, we could have multiple BSR candidates, right? In fact, let's do that. We'll configure multiple BSR candidates. Router 2 and router 3 will make them BSR candidates. But essentially, by doing the length of the hash mask length as 32, that means you're not using the hash mask, a hash mask, as part of the election process for each router. So we are going to do here, though, we're just going to do 32. Oh. IP PIM sparse mode. Yeah, that would cause a problem, wouldn't it? And let's do, well, we'll start with router 2. Then we're going to add router 3. So now we have a BSR. Let's look at our commands. Yeah, this lesson goes over a lot of the hashing, which I would not do that to you here on the stream. You would hate me, I'm sure. So let's look at a BSR. First of all, so we've added the BSR candidate router. Let's take a look at what that looks like. BSR. Let me try Wireshark here just to see. I don't think it will work. I wonder if I have. It should just pop into another window. Okay, it's not gonna work. That's all right. I gotta figure that out though. BSR pack capture. Hey, packetlife.net comes through again. Router 1 is a BSR, and routers 2 and 3 are candidate RPs with a default priority of 0. Let's take a look on CloudShark. All right, so this is, as we can see, the source. The destination, of course, is 224.0.0.13. And these are the bootstrap coming from router 5. Yeah, all these are coming from router 5. I guess it comes at every 60 seconds. But it's still, the protocol type is the same. Protocol independent multicast version 2, which is the default on Cisco iOS routers. And the type is 4, bootstrap. And let's see what the options are. Okay, it's got a group 0, which is everything. 224.0.0/4, right? We know that from yesterday. BSR ID is 1.1.1.1, and it already knows about 2 candidate RPs. So at this point of the capture, the RP announcements have already been made and have already reached the BSR. So the BSR is thusly letting the network know who those RPs are. You choose. Here's the ones I know about. You choose. And this is version 2. Interesting type is number 8. Candidate RP advertisement. Prefix count. And it's the same, everybody, right, by default. And there's an RP address. The hold time is 150. You know what? Let's look at the IP, or the PIM message types. I thought I knew them, but here's the IANA. Can't go wrong with this. This is official. All right, this is PIM hello. PIM 0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/0/ PIM message types. Wow, okay, there's quite a few here. Hello, register, we've talked about. Register stop, we've talked about. Join prune, we've talked about. Bootstrap, we're talking about today. Assert, we talked about. Graft, I've read about. And graft ACK. Now candidate RP advertisement. So this is the new one I have not seen yet. And I don't know about these. And it's cool. Links you to RFC right here. Good stuff. All right, where were we? Okay, so we looked at the packet capture. We now have RP advertisements. I'm sorry, BSR messages. There we go. I'm looking for the show command. So show IP PIM, and we have some new commands, new to me. BSR router. Some of these commands take a while to process, I've noticed. Okay, so here we have the... We know the default expiration is, I think, 150 seconds, right? I think we just read that. But the uptime, we have the BSR address. Now, how did it determine that BSR address? Oh, because we told it loopback 0, right? Okay, just making sure. Okay, so PIM2, everybody knows about the bootstrap information, or they should. Let's check down the line. Show IP PIM bootstrap, or no, it's BSR. Man, I wanted somewhere to be able to type bootstrap at the command line. There it is. Okay, hash mask length of 32. Now let's mix it up a little bit. Let's go to router 3. Where did I run that from? Yeah, router 4. Let's go to router 3 now. And let's change that hash mask length to 31, which means it's going to consider more bits than the other. So let's say IP PIM BSR candidate. What other options we have here? Just the, yeah, tunnel, or no, loopback 0. And then the hash mask length is going to be 31. So we're going to take one of those bits and use it to generate a hash to kind of influence the election of each router as to what BSR it wants to use. So router 4 should have received that information already. Ah, now it has elected 3, right? Because of the hash mask length. I wonder if we can show any details here. No. Okay. Let's go ahead and configure now router 1 to be the IP PIM. No, we don't want to do Canada RP. We want to do PIM. Is it the same command? Wouldn't that be cool if there's the same command as Cisco's proprietary RP candidate? Loopback 0, and then we can do, yeah. No, is that the same command? Because it is, and I know based on study with Boson that you can actually configure. I think you can configure both if you wanted to. You can configure both auto RP and BSR on your routers. I could be wrong there though. Let's come over here and see IP PIM RP. Yeah, send. Sorry, different command. Send RP discovery. Okay, we're not going to try that right now. Let's see. This one, we're just going to have one RP on the network. And let's see if now the other routers have learned. Okay, notice our tunnel. We still use a tunnel with BSR. Show interface tunnel. One should be the encap and the other the decap. Yep. Nice. Okay, let's see if the other routers now know. Show IP RP. What is the command? PIM RP mapping, excuse me. Yeah, it knows who it is. It says for every network, it's 1.1.1.1. And I'm using, this system is the this system, by the way, is the Bootstrap router. And this was learned via Bootstrap, priority 0, hold time 150. Yeah, that is a hold time. Sweet, let's go to router 4, make sure he learned it. Show IP PIM RP mapping. Also, it is using tunnel, right? That is the information, that's encapsulation happens on the first packet at least that goes to the rendezvous point, right? So this is the rendezvous point, and this is the BSR that told me about that rendezvous point. What does that show on router 2? Because he is a BSR. But does that mean that he still cedes that role to router 3? Because router 3 should be preferred. And it is, yeah, okay, cool. So R2, even though R2 can say, I am a BSR, I have evaluated as a router myself on who should be the BSR, and 3.3.3.3 wins, router 3. Good. So now we should be able to send. Let's make R4 also act as a host. And we will say, let's do a new tunnel interface. Interface L1, IP address. Let's do 44.44.44.44. We will do, we don't have to run PIM on this interface, but we can do IGMP, and we want to add it to router OSPF1. They need to know about this link. Network, 44, sorry. And then we're going to do IP IGMP join. Oh, back to the interface. Interface L1, IP IGMP join group. And let's do a ping. Interesting. I did say IP IGMP join group 239.111. I don't know. This is kind of an unusual scenario here. I just kind of did this on a whim. IP join group 239.111. That's what I'm pinging, right? Yeah, I'll bet if I put a host, we know that the mapping is working, so disregard that. I'm trying to go off script here. Okay, one other thing we want to look at is that RP hash. So let's go to router 3, show IP PIM RP hash. Oh, we have to know. Let's just put in a random. Info source, uptime, and it has a hash value, right? Interesting. It's actually using like a network mask. Yeah, because you could have multiple RPs as well and state the priority. RP selection is based on longest match for the group address, RP with the highest priority, or RP with the highest hash value, which is calculated with the hash function. And finally, if everyone was set to the RP hash value of 32, in other words, don't use any of the hash bits, then it will use the highest IP address. But this can be very useful, this hash value, to assign if you have multiple multicast groups. You can essentially do a little bit of load balancing that way. All right, that is going to end this lab here, folks. It's been good. I like BSR, and I can see why people want to use it. The fact that it's standard, right? It doesn't really seem to have any disadvantages over, just kind of first impressions. I could take one or the other. The only thing is about the hash. BSR seems to have more things you can configure, more sort of configuration options. I like it that it's clean and it doesn't require dense mode for the auto discovery or the special IP PIM. What is the command when you're only using sparse mode, but you want to allow dense mode for an interface? So that's not. What is that command? IP PIM auto RP listener. Yeah. So BSR just seems to be a little cleaner to me. But of course, they had the advantage. I'm going to guess that BSR came after Cisco put, like a lot of other things, after Cisco put auto RP on the market. Could be wrong. Just going to guess. But anyway, that is what it is. All right, folks. Great lab. Let's move on to the last point. Some trivia. HTTP REST API calls. So this is really good to know, I think, not just for the written exam, but if you've worked, I've worked a lot with load balancers, and also I'm now working with the Azure API, and everything in Azure, is pretty much accessible via API, and you're encouraged to do so. So I've gotten more familiar with these HTTP REST API calls. REST, of course, means restful. It's not, doesn't maintain state. So it's basically stateless connections that you can make to the IP or to the API, Application Programming Interface. And with HTTP REST calls, they're pretty commonly used, regardless of like which vendor you have or which API you're dealing with. They generally all use this sort of framework, right? With HTTP, you got get, put, post, and one acronym that has been used. And I'm sorry, folks, I can't really cite any reference here because I didn't keep a lot of good notes. I could not find I compiled some material, like a chart, like I tend to do sometimes, which sort of helped me sort it out, and it's in the drill sheet. And again, this may or may not be 100% accurate, but this is how I interpreted the information based on what I can find. But this may be helpful if you just see it in a chart, what I'm talking about. And my question, I know, is not really well worded. I made it up. But CRUD is, right, create, read, update, and delete. So they call these CRUD operations, which is a basic data operation, right? When you're dealing with data, you need to create, read the data, update it, replace it, right, or delete it. CRUD. So HTTP RESTful APIs that leverage HTTP typically use these 5 commands, and some of them are done on different levels. So the way the hierarchy goes is collection, I think of sort of as a folder or a function where you're dealing with a set of data below that. So you typically have, when doing API call, RESTful API calls, a collection of data, which is a collection of items. And then you have items, which are below that. So some of these operations are typically used at the collection level. Some of them are typically used at the item level. And I tried to make a chart of these. Like, this isn't hard and fast. Like, some of these I've got rarely used on a collection. Some of these I've got basically you want to avoid using this on an item level. And I know this is important working with APIs, but we've all seen get, right? We've probably seen put. So this is kind of your layout here. So post is generally done to create a new collection. And generally you will put items, which can update or replace items in a collection. You can do a put to a collection, but as it says here, it's rarely used, right? Get is to read. We probably used that before, especially work with and if you work with the F5, for example, or load balancers where you're making health monitors to monitor RESTful API services, you've seen this, right? You do a get to check, what is the status of this service, this API service? Is it listening? Is it up? Is it down? And of course, you get HTTP response codes, right? 200 is usually okay. You've got a 503 incorrect service. 400, I think, is incorrect address. You've got 404s. We've all heard of those, right? So 200 is usually good. Everything's okay. That's typically the response that you want when you do a get, for example. Get me this URL, and you get a response, okay, and all the information that you requested. So this is pretty basic stuff for the RESTful API structure. And as we mentioned, the put is to update or replace. So you often have an item there already. It might just be a shell, or might not have a value in the item, but put is going to update that item and put information there, right? Or if there is information in the item, you do a put, it's going to replace the information in the item, right? Patch is also a partial update. I haven't seen this myself. It's rarely used at the collection level. More often used at the item level, but in looking at PCAPs and things, I have not seen this. I have seen the other 4. And there are others. These aren't the only ones, but these are basically what I deduced are the most common. So I hope that helps. You will read a little bit about this, and I was trying to share some material, like source material, with Dufram earlier, and I couldn't really, like I said, I didn't take good notes. But I did reference, just to check and see if Nick Russo's revised Evolving Technologies Guide had information about this, and he does touch on RESTful APIs and some of these statements. So I found like post. Yeah, he talks about these four, right? A common API is discussed when there is a representational state transfer. I always forget what REST stands for. REST represents an architecture. This is under device programmability, by the way, in the blueprint. So we're talking about network device programmability and interfacing with APIs. And most often, you're going to use HTTP methods. Get, post, put, and delete, right? And URIs, or Universal Resource Identifiers. The end result is that API requests look like URIs and are used to fetch, write specific pieces of data to a target machine. This simplification helps promote automation, especially for web-based application or services. Exactly. Note that HTTP is stateless, which means the server does not store session information in individual flows. REST API calls retain their stateless functionality as well. This allows for seamless REST operation. And that's really the main area that he touches on in that, but even that is very succinct and useful. So I like it. And that's all I have tonight, folks. I do have one other meat chunk, and that is, well, I already posted that. So yeah, that was our trivia for today. Thanks so much for stopping in, folks. Hope you enjoyed it. Hope you found some use here. And, encourage me on. Towards that written. I am just some real talk here about the written and preparing for that and mindset. So I probably should have spoke about this at the beginning, but anyway, 68 days, and I really, really want to pass this time. Like, I failed twice, and the first failure was pretty much a wake-up call, right? The second failure was an aggressive sort of denial of where I am in the information for the written, and I got very aggressive and tried to just immodestly go in and think I could pass again with just, an intense 5 weeks or so of preparation. But I really want to pass this time. So I'm very serious about it, and what I'm considering to get more study time, besides the vacation days that I've carved out, which I'm pretty much going to exhaust, not all my vacation days. I'm going to have, we can only carry over so many. So I want to leave a reserve, of course, vacation going into next year. But I want to use all I can, otherwise, that I would otherwise lose. And I really want to pass. So what I'm considering doing to carve out a little more time is to, I try to make gym, I get up early in the morning and I go to gym, and I may cut back on a few days a week. That way I can stay up later, because I found once this week and once last week, I had to stay up late for work anyway, to do a change at 10 p.m. or later. And then once the change went pretty quick, and so that night I was able to get in. I was up. I'm like, okay, it's too late to really get up early and go to the gym. So let's, spend some more time working on this journey, right? And it really paid off. So I'm thinking just temporarily cut from 5 to 3 days on the gym and just hit it, man. I want to have so much momentum and energy going into it. So I think that's what I'm going to do. But anyway, yeah, let's keep on keeping on, folks. Thanks for hanging in here, for those who have, and wish you the best. Sending you good bits. It's Wednesday. We got plenty of time left in the week to make some good progress towards our next cert. So wishing everyone the best. Sending good bits out to the universe, and thanks so much for tuning in, folks, and your support and all the responses on Discord and Twitter and all the interactions. That's awesome. I really appreciate it. So we shall see you, folks, back here tomorrow, 7 p.m., same time, here on the Land Timber Stream. You all have a good night.